Right now, there is a device in your kitchen that Whirlpool, Samsung, and GE have never once mentioned in a user manual. Not in the setup guide, not in the safety sheet, not in the warranty card. It is a function that electrical engineers have known about since 1940, one used in field emergencies when equipment survival is the only priority. The industry now charging you $89 for a single specialized pouch has a $1.5 billion reason to make sure you never make that connection. Stay with me, because what your microwave can do right now, unplugged in the next 60 seconds, permanently changes how you think about grid-down preparedness. On March 26, 2019, the President of the United States signed Executive Order 13,865. The subject was not a foreign military, not a cyber attack, electromagnetic pulses. The order was titled Coordinating National Resilience to Electromagnetic Pulses, the first comprehensive whole-of-government EMP policy the United States had ever issued. The reason that executive order existed was September 1st, 1859, the Carrington Event. A solar storm struck Earth with enough force to melt telegraph wires across North America. Operators were shocked through their equipment. The aurora borealis was visible as far south as Cuba. In the Rockies, the sky was bright enough to read a newspaper at midnight. In 2013, the National Academy of Sciences estimated what a repeat event would cost the modern electrical grid. The number was $2.6 trillion. Months without power. Electronics wiped across every connected device not shielded at the exact moment of impact. The Congressional EMP Commission spent 17 years studying what survival would actually look like. And here's the part that a $1.5 billion industry has a very specific reason for you to never connect. A Faraday cage is a continuous metal enclosure. Michael Faraday demonstrated the principle in 1836. The physics work like this. Electromagnetic energy strikes the outer surface of the conductor, redistributes around the exterior of the metal shell, and bypasses the interior entirely. Whatever sits inside is invisible to the electromagnetic event happening outside it. The critical variable is mesh opening size relative to wavelength. The smaller the perforations in the conductor, the lower the frequency it blocks. Your microwave operates at 2.45 gigahertz, a wavelength of 4.82 inches. The mesh screen on your microwave door was engineered with holes smaller than that wavelength, specifically to prevent 2.45 gigahertz radiation from escaping into your kitchen. The FCC required it. The manufacturer tested it before the unit shipped. The physics that keep microwave energy trapped inside the cavity are the exact same physics that keep electromagnetic energy from getting in. Your unplugged microwave is already a Faraday cage. Verify this right now. Place your phone inside. Close the door. Call it from another line. It will not ring. The global Faraday bag market was valued at $720 million in 2023. By 2031, analysts project it reaches $1.52 billion. The average branded Faraday bag retails between $80 and $300 for a single phone, and this is where it gets dangerous. Not for you, for them. Because the device currently on your kitchen counter can shelter a backup phone, an emergency radio, a solar charger, 2 hard drives, and a battery bank simultaneously for $0 additional dollars. The only thing standing between your microwave and full Faraday function is a decision made at the factory, not an engineering limitation, a decision. In about 60 seconds, I will show you the 2 materials that close that gap for $13. Appliance engineers know exactly what a microwave cavity is. They designed it. They tested it against FCC electromagnetic leakage standards before every unit shipped. What they chose not to include in any consumer model produced in the last 4 decades was a sealed conductive door gasket and a grounded chassis. Not because those modifications were difficult, because they added manufacturing cost. And because activating that function would hand you a $0 solution to a problem that a $1.5 billion industry depends on you paying $89 to solve. But someone made sure you would never find out. Here's the fix. Aluminum heating and air conditioning tape, available at any hardware store for $5 to $8 per roll. Applied in one continuous line along the door perimeter where it meets the frame. No gaps, one complete circuit. That closes the primary gap in the shielding. A sheet of cardboard cut to fit the interior floor prevents static discharge from the metal walls to whatever you store inside. 2 materials, $13 total. The cage is functional. Here's the exact procedure. Step 1, unplug the microwave from the wall. A grid-connected appliance is wired into the thread. The cord comes out first before anything goes inside. Step 2, apply aluminum heating and air conditioning tape. Not regular duct tape, not foil tape, aluminum heating and air conditioning tape, in one continuous line around the full door perimeter where it meets the body of the unit. One complete circuit, no breaks. Step 3. Cut cardboard to fit the interior floor. This is your insulation layer. It keeps your devices from making direct contact with the metal walls. Step 4. Run the phone test. Device inside, door closed, call it from another line. No ring means the shielding is working. A signal means there is a gap in the tape. Find it, seal it, test again. What to store inside? A backup burner phone with emergency contacts preloaded, a USB drive with digital copies of critical documents, a hand crank radio capable of receiving NOAA weather alerts, a compact solar charger, and a fully charged external battery bank. Total investment, $13 in tape and cardboard. One branded Faraday pouch at Best Buy, $89 for a single device. Here's the part that stopped me. The magnetron inside your microwave was not invented to cook food. It was developed in 1940 by two British physicists, John Randall and Harry Boot, at the University of Birmingham. The specific goal was a radar emitter compact enough to mount inside a fighter aircraft. The device they produced, the cavity magnetron, was so strategically critical that it changed the outcome of the Second World War. In August 1940, under a diplomatic exchange called the Teasard Mission, Britain transferred a working prototype to the United States. American scientists at the time called it the most valuable piece of technology ever brought to U.S. shores. Percy Spencer, a radar engineer at Raytheon, noticed in 1945 that a chocolate bar in his shirt pocket melted while he was standing near an active magnetron. He filed the patent for the microwave oven that same year. The first commercial unit shipped in 1947, 6 feet tall, 750 pounds, $5,000, the equivalent of $62,000 today. The radar technology that helped win the Battle of Britain is now sold at Walmart for $79. And for 80 years, not one page of its user manual has mentioned what it actually is. The 1859 Carrington Event happened before the electrical grid existed. The next one will happen after it does. Executive Order 13,865 is in the Federal Register. The Congressional EMP Commission's findings are public. The National Academy of Sciences put $2.6 trillion on the damage estimate. None of those documents told you to look in your kitchen. The Faraday bag industry is counting on that gap. The appliance industry never had a reason to close it. You now know what $1.5 billion depends on you not knowing. Every share, every comment, preserves what they tried to erase. The cavity magnetron won the Battle of Britain. It gave the Allies compact radar that fit in a cockpit. Then, in 1945, an engineer pointed it at a chocolate bar in his shirt pocket by accident. And 8 decades later, someone is reheating last night's pasta with it while the news runs a story about solar flares in the background. That appliance on your counter, it was always a shelter. Nobody put that in the manual. That's it for me today. Thanks for watching, and I'll catch you in the next one.